Hello everyone. We are now into section 2.7 and 2.7 is about combining functions. We will first look at how the notation and things for adding, subtracting, multiplying, and dividing is, and then we'll move from there into composition, and then we'll just talk about all of those things in different formats. So first we'll deal with formulas, like if f and x have formulas for them, then we'll look at possibly a table, if they have tabled values, and then also looking at graphs as well. But let's first jump into just the definitions when we combine functions. So we will have let f and g be functions. And they're going to have domains with domain A and B. So f has domain A, g has domain B. Then the functions f plus g, f minus g, f times g, and f divided by g are defined as follows. And they are actually defined as you think they should be. So if you want to define this function that we're going to call f plus g, and it will apply to some x value, to evaluate it, we will take f of g, or to come up with the formula, we'll take f of x and we will add g of x. If we are doing the subtraction, I suppose I probably could have put a plus minus in there. Kind of looks like I did. We would do f of x minus g of x. The product function, fg, is going to be the product of f of x times g of x, and then f divided by g, or the quotient function, would be f of x over g of x. Okay. We are going to talk about their domains. I did go a little bit quickly through that, but I think that those make sense. It's kind of intuitive. You're going to do the addition function. You would actually add the two functions together. The domain I want to think about is, in order for us to evaluate this, we need to be able to evaluate f, and we need to be able to evaluate g. So if we're going to have a value, that value has to go into both of those, so that value has to be found in both of those domains. So the domain of our combination functions, these first three at least, we have to be able to evaluate f of x and g of x. So we're going to be looking for what a and b have in common. So that is designated or written as A intersect B. So it is the overlap of those two. It's actually technically called the intersection. The overlap, their common areas. So that would be what the domain of f plus g is. That would also be the domain of f minus g. That would also be the domain of f times g. And this is like an upside down U, kind of like we've used the union when we were doing interval notation. This is the intersection, what they have in common. Here we have to be a little bit careful because we are dividing, so we have to make sure that we do not divide by 0. So the domain of this one is going to be all the x's. I'm going to use set builder notation, all the x's, such that, first of all, it has to be in the intersection, but on top of that, so we're going to have another such that g of x does not equal 0. So we're going to also have to make sure that that second qualifier holds as well. So let's do an example. Let's look at f of x equaling x squared minus 3, and we'll look at g of x being our simple square root of x. Okay, and let's say I wanted to do, what is the domain? First of all, our domain of f is, well, this is going to be all real numbers. So negative infinity to infinity. G of x, we can't take the square root of a negative, so our values must be positive. So let's go 0 to infinity. Let's throw another function in here just for fun. Make it a little bit more complicated. Here we can do almost all values, except we can't let x be 2, so we're going to have to throw out the x. So envision a number line with a big old open hole at 2. So writing that in interval notation, we're going to start at negative infinity, go up to 2, not include it, and then start again at 2 but not including it, all the way up to infinity. And again, we want both of those groups combined, so we use that union symbol. All right, let's look at what f plus g of x would look like. F plus g is going to be adding these two functions together. So x squared plus 3 plus that square root of x. Finding the domain is what these two have in common. So where they overlap. This is all real numbers. This is just positives. So our domain is going to be the positives because that's what they have in common. Let's look at what, how about g of x, whoops, g plus h of x. So that would be this one plus this one. So I'd have that square root of x plus 1 over x minus 2. And yes, we could get common denominators and bring them together, but that's not what this lesson is about. This is more about finding domains, understanding the addition function as you add those two functions together. Now our domain here is what these two have in common. I'm going to draw a little picture so you can maybe see it better. So here's my 0, here's my 2. G goes from here all the way up. H throws out that 2. So I want to know where they overlap. They overlap here and here. So our domain is going to be from 0 to 2, and then from 2 to infinity. So there is my domain. All right, let's do a couple more. Let's look at, let's do a division problem. Let's do f divided by h of x. Okay, so I'm going to take this one, that x squared minus 3, and I'm going to divide it by this. Okay, I am going to clean this out just a little bit because that's like taking x squared minus 3 and multiplying by the reciprocal. And I'm going to leave it that way. Okay. Now, when we look, if we were to look at just this formula has no restrictions on it. However, we have to remember where it came from. It came from simplifying this. So here we had to make sure that x did not equal 3. So our domain does have to go back to those original pieces. So we want that intersection. What do these two things have in common? And it is this. We still have to throw out that 2 because we still have to make sure that this bottom can be dealt with. Not after we've simplified it a little bit, but how it looked to be. And we will talk a little bit more in detail about things like this later on. These two are not identically equal, but they are identically equal over this domain. If we were looking at just this function, it would have a different domain, but we are not. We're looking at what f divided by h is. I'm going to do one more problem with these guys, and let's do it at a value. So let's look at f plus, let's do a subtraction, minus g of, let's say, 9. So this is f minus g of 9, which means we can, if you wanted to, get a formula and then substitute in the 9, or we can just do f of 9 minus g of 9. So I'm going to go up to f, put 9 in there, so I get 9 squared is 81 minus my 3, and then minus g of 9. 9 in that square root gives me a 3, so 81 minus 3 gives me 75. Okay, I'm going to stop the video here and come back in another video and discuss our next piece, way to combine functions. We have added, we've subtracted, we've multiplied, we've divided. The next piece is we are going to combine them through what we call a composition of functions, and that is a little bit more in detail. So that will be in our next video. See you in a few.